Hello, my name is Evan Santos. Today I will be discussing the naive Bayes algorithm that was given to us through the reading for this assignment. Here is a table of contents to just discuss what we will be discussing about specifically. So, as we see for slide 3, we're going to be talking about what is the naive Bayes algorithms. And from 4 to 5, we'll be talking about section 2. And from 6, we'll be talking about section 3. And from 7 to 10, we'll be talking about section 4. Then for 11, we'll be talking about the experiments they did, so the experimental evaluation. And then for 12, we'll be talking about the conclusion and just wrapping all this up. Thank you for listening. So to start off, what is even the naive Bayes algorithm? So to break it down, the naive Bayes algorithm is a probabilistic clarifier that is commonly utilized for tasks like text clarification. It's so good because it's simple, efficient, widely used, and specifically for text clarification again. So this utilizes Bayes' theorem, which is something we'll talk about more later on. But basically, it's a theorem used to calculate the probability of a sample belonging to a specific class. Another just kind of brief thing about the theorem is that the algorithm utilizes it to calculate the probability of a sample belonging to a particular class given its features. But again, we will expand more on that later on in the slideshow. So now we're going to start with section 2.1, which talks about what is a text classification. So text classification is practically the process of using the content of text to determine the category of text under a given category system. So in simpler terms, it's the process of assigning a category to a document. So as you can see in the little diagram we have on the right corner, it's like for our emails, like when we get a spam email. So as we can see, the spam emails and two spam emails and then one just normal email is going to go through the classifier, and through that, it's going to assign where those like emails should go. So as you can see, the spam emails are going to go for the specific spam folder, and how the normal email is just going to go straight to the inbox because it reads it as either like if it's important mail or just again spam mail. Now we're going to get into section 2.2, where we talk about specifically the naive Bayes text classification and the Bayesian theorem. So to go back, as we talked about earlier, with the naive Bayes algorithm is being based on the Bayes theorem, which again is a calculation of probability that a document belongs to a specific class given the word that it contains. So as we see up top, we have the equation for it, where pH represents the prior probability of a class, and phx is the posterior probability based on more information such as background knowledge, and pxh is the posterior probability of x under h, and it reflects how well the data fits a class. And basically, whatever calculates the largest posterior probability, we take that document to the class with it. Now we're getting into section 3, which is the naive Bayesian network structure, and I'll refer to the naive Bayesian network as just NBN for now. But so basically, the NBN is a supervised learning model. It has two main models, where it's the polynomial, and I'm sorry if I pronounce this wrong, but the Bernal. Again, I'm sorry again if I pronounce that wrong. But basically, it also mentioned how the naive part of the name comes from the assumption of class conditions being independent, which is something we're going to talk about in the next slide, and how that could stir up like problems and issues. But in the text, it stated how the Bayesian network is a probabilistic network, which is a graphic network based on probabilistic reasoning, and the Bayesian formula is the basis of this probabilistic network, which is the formula we talked about before. And it talks about two stages in it, where it talks about training, which is kind of like the estimate conditional probability for data, and the classification, which basically just assigns like new text to the classes with the highest posterior probability. And as you can see, we have a chart in the corner that kind of represents that like network structure, and it's very simple how we see the class nodes connecting to those like feature nodes on the bottom, so like x1, x2, x3, and etc. So now we get into section 4, where we start off with like the problem that naive based like bias based algorithms provide. And for one, when we talked about it being like the features being raised as independent, uh, that could cause a problem because that's not necessarily true when it comes to approaching data types, when usually they are like dependent on each other. So that can cause issue, and a challenge that like may occur with text classification is that there can be too many features, meaning that feature space can contain like hundreds of like various different words and data types and phrases. So this can make it hard for learning algorithms to handle efficiently due to how large the space is. So, for example, few networks can handle so many like input nodes, and Bayesian models can be very difficult to deal with like computationally when approaching high dimensional like feature spaces, unless we assume the features are independent, as we talked about before. So now we're going to talk about the first strategy that section 4 talks about, which is feature selection. So basically, feature selection is to delete words without information according to the corpus statistics. So only keeping the most informative words. So step 1 would be selecting like a specific algorithm, and the ones it gave in the text were like term frequency, inverse document frequency, information average ratio, and class discrimination, and etc. So each measuring basically how important a specific word is for classification. Step 2 would be calculate word agen value, which basically means word scores. So the higher the word score, the more useful a word is. And now we determine the size of that. So cumulatively, the probability threshold. So that's the equation we see above in the right corner that it'll use, and it basically just keeps the most important words or phrases until the combined probability reaches its set limit. So now we're going to strategy 2 from section 4, which is mutual information. So mutual information is it's said in the text. It's an important concept in Shannon's information theory. The method to detect the degree of correlation between event sets, and the higher the mutation information is, the stronger the bond is between a class and a word. And it's meant to filter out words with weaker associations. So we have an equation on the bottom from the text. And this is where we see that so WI and WP are represent two different words or features, and CJ is a specific category or class. And sorry, and then we see PWICJ, which means it's the probability that the word appears in like the documents of class CJ, and we see PWIWP, which shows the probability that both words like appear together in a singular class. So now we're going to get into section 4.3, which just talks about strategy 3, and that's system structure. So basically, it's dividing the system into two processes, and those two processes are the training process and classification. And in the text, it says the training process is the Bayesian text categorization algorithm based on vector space model, introduced in the above chapters to train text and construct a classifier. And it basically just handles larger scale text at like a better rate, which means a faster speed while maintaining its accuracy. So as you can see in the side, we have like a example of the system structure, how we see it's like kind of like two different ones and it's split, and we see how they all connect to each other. So now we get into the experimental evaluation. So basically the experiments they did with the strategies, and these are basically the tests. So in the experiment evaluation, they tested their new improved version of the naive Bayes algorithm on various data sets. So they already noticed right away that the improved models had a way better accuracy compared to the standard version, and which also was like way more efficient. They also noticed how much more stable it was as well. So this proves that their methods like feature selection and like mutual information worked very well. And we could see for like the first one, for example, we see that like its highest points are at 0.3 and 0.4, and that basically reads it as how I'm pretty sure how accurate and like how stable the features are, and the lower it gets, that makes it like weaker and less stable. To conclude, as we see the rapid growth of internet, it generates information that can be like unorganized and can make the process of finding what we need like inefficient. But luckily, we now know that the text categorization solves that issue, like the naive bias model, which is very popular because of its convenience and its simple approach to solving complex issues. But with its flaws, like as we talked about earlier, like reading all features as independent can make those complex issues more complex. So that now that we see after testing the strategies and improving the model, we can see how the enhanced version of the naive bias model can perform much more efficiently and accurate.